Hello, welcome back to our coding sessions for Bangalang, our language which is, what do I say? It's low-level, explicit, procedural, compiled. I feel like those are the main aspects, and it runs on the CPU and the GPU. Here's a little kernel. It's very tiny now. I like how tiny it is, actually. Where we can just tag it with GLSL. That means it's running on the GPU. Now it's running on the CPU. Now it's running on the GPU. Very easy. At the end of our last session, we were refining this so that we could use a variable here. We have to cast it, which is not great. We'll fix that at some point. But we can put a variable so we can have a dynamically sized array here. And it shouldn't, if I don't specify an allocator, then that means by default we're putting it on the stack. And on the stack you shouldn't be able to do this. You'd have to put a hard-coded number there. And when I tried this last time, we got this error, and I sort of thought, hey, that doesn't sound like the right error. But then when I looked more closely at it after the video, I saw it says line 78. So it's actually complaining about here, where this procedure is expecting a slice of these, but it's actually getting an array of unknown size of these. So the problem with that is, so it's not catching the error here. So this is a legit error down here, actually. But it should get caught here, and it should say, hey, you can't do this. And when I looked at my assignment stuff, I found that because we added this check for it, somewhere down the bottom, here it is. We said it can't contain non-fixed size arrays in our type when we're declaring, and because before that we do this sort of conversion stuff. So we change, if there was an array with a dynamic size, but we're using some allocator like VRAM or heap or something, then it actually gets converted to a slice, so it won't trigger this. But this here is within this condition, so it's only going to be for heap or VRAM allocated stuff, where actually I wanted to apply it to everything. So we move it out there. And now we get our error. Type cannot contain non-fixed size array sizes. Non-fixed array sizes. I feel like that's confusing. Maybe not the best wording. So then if we put VRAM back on, it should accept it because it will convert it to a slice. Yeah, so that all works. Okay, so I just wanted to do that one little fix first. Now let's have a look at our list of things to do. We're working towards this query core count. The last thing I wanted to get done before we tackle that is this. So slice comparisons should compare the data pointed to by the slice, not the slice object itself. So I think for that we can go to generation expression, and this is where we have generate expression any. So this is for any data type, and it will do, it's basically the only thing that can happen here is comparison stuff, either equal or not equal. So this is handling a few different cases, but I think I'm going to take a copy of this actually. And let's put it up the top and call it generate expression slice. So if we come across a slice, I don't know if we need all these same parameters or not. Let's see. looks like it wants result type node as well, but let's see. I'm not sure if we're actually going to use them all or not. Let's find out. So how does this happen? So the main difference is that we want to use we have this count here. So what we're doing is basically we're like loading up 2 addresses into these registers to be compared. And then we're saying how many bytes to compare. And then we're repeating this comparison operation. And we have the special cases for like if either side is nil. Now, if either side is nil, that effectively means that the length is 0. Move AL 0. So what do we need to do here to make it work? I think the main thing is that like these addresses, so they're pointing to the address of the slice, but we want it to point to the address of the first thing within the slice. So it's almost like we need to do this twice. And I guess for the other side too. So this doesn't actually need a parameter. Maybe I can smooth this across. So do this for the right-hand side as well. So basically this is just saying like, okay, let's grab the address of the slice. And once we have the address of the slice, then let's grab the address which is the first element of the slice, because a slice is an address followed by a length. So now these hopefully are containing the data pointed to by the slice. I'm trying to remember how this stuff works. But maybe we can avoid this altogether, because if it's an immediate, well, I guess the first thing we need to do is compare the lengths, don't we? And if either of them is a nil, then that's a 0 length. Okay, let's do that first. So first we need to compare the lengths. So to compare the lengths, that's just a compare of 2 different locations. So we'll say compare lengths. So we need to have those 2 lengths, don't we? So the LSH, RHA. So if the left-hand side is an immediate, that is to say if it's nil, then then I guess we just can use itself, because it'll be the immediate 0, which is the length of an empty slice. Otherwise, we want to get the memory of this. So let's go to operand. I think this is how we do it. So if this is a slice, is it always going to be memory? Yeah, a slice can only be in memory. So if we go LHS length location equals that, and then if it's not an immediate, then we can say LHS length location dot offset plus equals address size. So then that should get us to the length item within the slice. Yeah, I think that's right. So let's do that. Let's do that for the right-hand side also. And if it is an immediate, then it should, this location should hold the immediate 0, which is fine. So then we can say get the operands of the lengths and put them into here, do a comparison, and we can do jump not equal. So we're going to have to so there's like lengths not equal. So we need to jump to something. I guess we're going to use an index for this. So it's like, what would the label be? It'd be slice compare set. I'm going to call it that because that's kind of like, because we're going to go down to the part where we do the setting. So if we put this here, I guess we don't indent our labels. We need an index. Slice compare index. So let's grab that. So we'll get the next label index. Was it actually called next label index? No, I think it's just called label index. Yeah, that seems happy. Okay, and we need to put that in here as well. So there and there. So what that means is that if we compare these lengths, if they're not the same, then we jump to this label, which is here, and then we do our setting. And because this compare has set the flags for us, then this should work. It should always evaluate to the correct thing. Otherwise, so we've handled all of this stuff. Otherwise, so we know we're not doing a nil compare, so we use this guy. We put the correct addresses in, and we compare the lengths. So we know the length is the same, so I guess we can just say the left-hand side length location. We put into here. Is that it? I mean, this here looks pretty funny, but I think that's it. Compare the lengths. If they're the same, then we do this weird thing to get the actual data within the slice. We get one of the lengths, which we know are both the same, and then we do our comparison. Yeah, I think that's correct. So then to test that, we should be able to say like, if we say foo equals a big string, then we should be able to say if foo, so where's big, 0, 1, 2, 2, 3, 4, 5 equals big, string.println big. That should hopefully work. Oh, string.println. Ooh, that did not work at all. Okay, probably we've just got some bad formatting happening. So 140. Yeah, I thought it'd be something crazy like this. So that's for the count. Here's the count. So I think that should be a %s now. I think that's what it is. Getting there, 135. We're comparing two memory addresses, which I think is probably not allowed. We probably have to put this one in a register. Is there anything else? 143. That should have a colon on the end. Yeah, without a colon. Okay. So our label should have a colon on the end. And when we're comparing the lengths, we need to say left-hand side length register location. Copy to register this guy. We probably need to specify more stuff, don't we? Context. Yep, that's the source. The number is the register number, and then the type node. But is that register number gonna cause trouble? Let's see, we might have to put +1 on this so it doesn't conflict with other stuff. Copy to register type node. So the type node is the well, it's I think I have this. I mean, it's not quite the right name, but index type node. Yeah, which is an i64, which this should also be an i64. It's a bit weird to call it index type node, but I think that should be fine. Indexes and links, I use kind of like the same type. Okay, we're crashing. We're crashing when we run. So the compare links looks good. So copy to register. Yeah, I said I was copying into, yeah, see we're copying R11 into R11. I feel like this might be a problem. Because then later we use R11 as the address. Yeah. So I think this should be a +1. Yeah, okay, that works. Well, I mean, it doesn't crash, but we didn't see the correct output to be. Yeah, we get not big. So the equality of those, so these are both slices. This is implicitly a slice. That's 3 long, 2 to 5, 2, 3, 4, 5, 0, 1, 2, 3, 4, and then 5, which is not actually included. So this should be the correct thing. Wow, it's quite a lot of... So we take 2, we compare it to, I guess it's the length of our string, string 0. Yeah, I guess it's, yeah, the length. Then we compare it to 0. I want to improve this. I want to make them unsigned. Then we only have to do one check. That'll simplify things a bit. Then we have our R11, which takes that string in, the address of the string, and then we copy the length of the string here, multiply the length of the string by the size, and then, Oh no, this is not the length of the string. This is the index. So we take the index, multiply it by the size of an element, then offset by that. Then we do an allocation. I guess we're allocating this slice here. We copy whatever's in R11, which is our address, to the newly created thing, and then we grab 5, which is the second, that guy there. We compare it to, compare it to RSP plus 8, but we've just created a new slice. We've put the pointer into it, the data pointer, but we haven't put the length into it yet. So comparing these two, it's not giving us an error, but that's an issue. That, like, when do we, where's RSP plus 8? So here we put it in. So we're doing bounce checking before we've even put it in. Okay, but this bounce checking is not causing an issue, so that's okay, I guess, for now. But then we put it in, then we subtract, yeah, because we're putting in the 5 as the length. Yeah, and that's not actually the length. We need to subtract 2 from it to get the actual length. So that makes sense. That's the R12, which is still this guy, still 2. Okay. Then we compare that with 0, make sure that it wasn't negative. So make sure that the subtraction didn't result in a negative number. Then we copy the stack address. So that's the newly created slice to R11. We copy the length of the new slice to R12. And we compare that with the length of the string. Cool. And if they're not equal, we jump. If they are equal, then we do this crazy shit, which I hope is right. This could be the problem, actually. So, I mean, I guess one way to check whether it's the lengths or the other thing is if we cut this out, then it will only compare the lengths. Okay, and that part is happy. So let me, what are we actually trying to do? We're trying to dereference. So can I find where I'm doing dereferencing before? So here's a dereference. That's type checking a dereference. I kind of want, not that, but like, here we go, dereference. So to dereference, we copy to a register and we use that register as memory. So we copy it to somewhere and then we use that as memory. So here we're copying it into a register. We're using it as memory, but we still have LEA. I think maybe we don't need that to be LEA. We just take it as memory and put it in there. I don't know what happens then. Ooh, okay. I think that might be right if I say biff. Not big. Okay, cool. All right, I think that's good. And obviously that's, you know, the lengths won't be equal. Okay, so now we have string comparison. well, we generally have better slice comparison, which results in us being able to do better string comparison. So I think that's like lopped that off the list, and now we can actually do this query core count business. So I think I'm going to put that in threading. Just chuck it down the bottom, a little utility procedure. Get core count, CPU core count, which is a procedure that results in a, I feel like U8 is probably enough, probably a big enough. If you've got more than 255 cores, you're doing well. So how are we going to do this? So now we need to actually read and parse a file. I think we can get rid of these. So to do that, we need actually some new syscalls. Oh, did I close that window? I feel like this was it. I know it was like a Chromium page. There we go. Here we go. So here we go. We want to be able to read. We need to open a file, read a file. I was actually thinking about like reading the entire file, but I think if we have another look at this, this is our file. So if we go back to the top, all of these entries actually contain this CPU cores 8. So maybe I just need to read like a chunk of the file, a decent chunk of the file, search for this, and then get this number out. So we need to open and read for sure. Open is number 2, takes a file name and flags and mode. Okay. File name, which I guess is a C string. Yeah, because we don't supply a length, so this must be null terminated. And then flags and mode. And that'll give us back an I64, which is our file descriptor. So file name will be danger untyped. I think I said it was syscall 2, right? Yeah, syscall 2. Then we have our flags and our mode. And if we have a look in here, yeah, I was looking at this earlier. So mode is like optional, I think. You don't always need it. So I might just put that at a default of 0. And then for flags, where was it? The argument flags must include one of the following modes. These guys. So I'm going to have to add these. And I'm going to have to figure out what the values actually are. So according to this random guy on the internet, read only is 0, write only is 1, read write is 2. I don't know if that's always going to be the case. read, write, but I'm going to use it. Okay, so now we should hopefully be able to open a file. I also want to be able to read a file. And actually, this here I want to change because I had write set up. It's assuming that we're going to write a string, but a file could be binary or whatever. So I think what they actually wanted was buffer, which is like just a pointer to bytes. And then count. They call it count. They call it buff and count, but I'm going to use buffer. I don't really like using I64. So size T. The size T, I feel like that's actually an unsigned. Yeah, I feel like that's actually an unsigned 64. Let's put it unsigned. And file descriptor, why don't we call that unsigned as well? We're going to have to like, oh, we could make all it, no, let's, I think we're going to get too carried away. I have a note to make things unsigned if they can be, and we'll get to that later. So when we're writing, buffer and count, and when we're reading, so now we're reading into this buffer, and then we can also give a count, right? Yeah. And that should be syscall 0. Okay, so now we can open and read a file, I think. So if I say linux.open/proc/cpu info, did I need to supply anything else? Oh yeah, flags and mode. So we need to read it. Then we get the file descriptor. I'll call it CPU info. And then if we declare a buffer, which is, I don't know, it's pretty big, like 1,000 bytes, should be big enough. And then we do a read with the file descriptor. Into buffer.raw, buffer.length. And I think actually it returns, yeah, return value number of bytes read. And I think write also returns that. Number of bytes written. Yeah, so we should add returns to these. And then we can go read count is that. And then we should be able to go strings.print line. Buffer, and we'll just say, you know, the amount of the buffer that was read into. And we want to actually call that, right? Which we want to do a boomstick. So at the moment I set up my thread pool here. I think I'd like to move it to a init. And, you know, so it doesn't just happen when the program loads. The person using this API has to actually call a init for it to do this. I like that because it's a bit more explicit that, you know, just random stuff's not just happening without you really knowing it. And it's the one argument I've found so far to have a main, like an explicit main function instead of just having code in the body of procedures like this. I mean, in the body of modules like this. Let's see. For now, we'll just leave it as it is. So yeah, we'll just declare it here. And then we'll say pull.workAccount equals 8. And I'm just going to do this. And we'll just return. Let's just return 8 for now. Then we can do that, and it'll be threading dot. Okay, let's see what happens if it prints that out. U8 and I32 are not compatible because this returns an I8, so U8. So let's change it to I32. Wrong number of parameters passed to procedure write. Expected 3, found 2. Oh, right, because I changed the signature of write. But then probably in strings, where I call write, we need to do this. And this is a length of 1, I guess. Well, I guess we have to do like that because we have to get the raw from it. What's that? Okay. All right. Look at that. And now we have a bunch of stuff printed out from the file. Kick ass. And here is our CPU cores. This here, I believe, is a tab character. There's a couple of tabs. Could be nice if we supported tabs. Right now we support new line is the only escape character you can put in. And I don't think you can escape the escape character. Like, you can't do this to prevent it from escaping. It's so basic right now, the string handling. I think it's in generation of a program where we do the string literals. Yeah, here we go. We replace /n with, we have to do this 10. So this is saying, like, if we go to the bottom of this here, the very bottom, here's an example. So this is how you put a new line in. So we're defining bytes, so you can just find like some string data, and then you can say, okay, now we're defining a 10, which is the ASCII code for new line. Then some more string data, which is kind of pointless in this case. And then another new line, and then more string. So that's how we do it. So I think if we have /t, I guess we don't need to declare it anymore. We'll do it with the C string as well. So then we need to find out ASCII tab, decimal value 9. Okay. So we'll replace that with a 9. Cool. I think that should mean that we support, I feel like there was somewhere else. In here, what the hell was this? GLSL, right hand side node dot value, final string. I think this is the GLSL code, source code, which we don't put any tabs in. So I'm just going to leave that for now. But yeah, now we should be able to put tabs in our text. So then I think what we can do is say for index, I'll call it an I64 because we'll compare it with this. Index is less than read count minus, yeah, so let's put, what was it, CPU cores. CPU cores prefix is CPU cores /t colon space. I think that's it. So we want to keep reading through the string until we don't want to go further than, like if we get to a point where it's not possible to fit in the rest of the string, then we'll stop. And we'll keep incrementing index. And then let's say if buffer index index plus this dot length equals that. So we're taking a slice out of the buffer from the current index to, and it's the same, the slice that we're taking out is the same length as this, and then we're comparing it to this. So if we ever find this prefix, then we're going to take the call count string is going to be a slice of the buffer here, and it's only going to be like one character. Yeah, it would be easier just to take the character itself, I think. But I think we want a string because then we can feed it into our strings dot a to I. And that should be our result, which we have to convert from I64 to U8. Maybe, and we'll default to 1, fallback to 1. If we can't figure out how many cores there are, we'll just say there's 1, which sucks, but what to do? And we'll just print out that core count string. Hey, it printed out 8. Okay. Huh. All right. I guess that worked. That was not so bad. Get CPU core count. So we're parsing a file and grabbing the core count out of it. Sweet. Happy, happy, happy. That's cool. We're only 45 minutes in and we got that sorted. I want to do SOA next, but I think that's going to take a bit of time. So let's see if we can tackle some small things. Here's a few things that we can try. But actually, is it in here? Oh, yeah, it's at the bottom here. This I've been wanting to do for a while. So in type checking, we getting lost. I don't need that anymore. That's right. When we type check an assignment, there's a lot of stuff in here that's really specific to static procedures. And in generation, you'll notice that there's a separate procedure generation thing because procedures are just so different to other assignments. They're parsed as assignments, but they're just so unique. And I want to split it out also in here just because the code is so different from procedures. And also from context, we know exactly when we're dealing with procedures. So yeah, this is something I've been wanting to do for a while. So if we know that we've got a left-hand side, oh, this might solve this issue also. Because we know the type will not be null. So we do have an issue here where you can redeclare procedures with the same name. This is an existing issue, and I do have a note for that as well. So we're not going to prevent that now. But we could take this condition out. So this is just for regular assignments. For procedures, if we're type checking a procedure, we have established that the left-hand side already has a type. So we know it's a declaration. This obviously makes sense. We know it's a static procedure. So yeah, if we haven't specified a body and it's not external, then we do this. So again, we know it's a static procedure, so we can take that condition out. Yeah, so that's all static procedure stuff. And now if we do have a right-hand side, then if it's a static procedure, this is what we care about. And this stuff here is if it's not a static procedure, so we don't care about that. Can do like this. I'm not sure why that's gone green. Probably it's declared somewhere further down also. I mean, we know that we're going to have it, so we could even like just put it right up here. Oh yeah, because we do have it here. Okay. Yeah, let's just do that. Okay, so I think this is where we got down to it. I remember seeing this. So I think this is the next code. So this is saying if left-hand side did not have a type, then grab it from the right-hand side, which doesn't make sense for us because we know the left-hand side had a type. If it's a static procedure declaration, because that's how we check, right? Let me just show that. Maybe that makes things a bit clearer. Is static procedure statement. So one of the things we check is whether the left-hand side is a static procedure, which means that it has a type of procedure. If it doesn't, then it's not a static procedure. So we know there's a type. And now the only operator we can use is assignment. We can't use any of these other ones. So basically, I think we can just cut out all this special code and basically say, look, if we're using anything other than assignment, it's a no-go. Could not determine type. So like I said before, we already know the type. And we know the allocator is a static one. We know it's not this heap of VRAM stuff. So we can cut all that out. It's already in the identifiers. So it's already in the identifiers, so it would not have gone in here at all. Because we do a first pass where we look through all the statements and then we record the procedures and the identifiers, and then we come through on the second pass and do the actual type checking, which is this part. So the identifier is already in there, So that's not going to get called. Okay, I'm not sure. I must have too many brackets or something somewhere. Oh, that's going to be a pain in the ass to find. What did I do wrong? Assignment operator is not valid for declarations. Yeah, I think that error is still right. Okay, maybe I'll do the weird thing and actually see what the error says. Redeclaration. Ah, okay, yeah, because it was elsewhere. So let me just get rid of that. Okay. Cool, so that's the procedure specific stuff. Now we go back to assignment and we take out anything procedure specific. So this is to do with procedures. This here is to do with procedures. So you can see like the crossover where where the code is good for both is like quite small. So there's not really much point in having it in the same place. So it is static procedure. Let's get rid of this. Maybe we can move this one down to here where it's actually used. So yeah, all this stuff. And this is what we cut out of the other one. This is making sure that if the left-hand side doesn't have a type yet, we give it from the right-hand side. This is our more complex operator checking, which we keep. We make sure that left-hand side type could be determined. We do our allocator stuff. Yeah, so this stuff all stays. Cool, now we need to make sure that we use this guy where it makes sense. So I think it's statements is where we do all this crazy stuff. Yeah. Import statement, so procedure statement. But we don't do the type checking here. That's right, we do it. Oh no, we add it to the queue. And that queue, I think, is it in main even that it gets processed? Or no, we have a type check program. That's probably it. Here we go. So first we type check the main module, and any procedures it puts on the queue get type checked here. We know that these procedures just have one statement. I think that's it. I think that's the only place. Yeah, seems happy. Okay, great. Happy to get that solved. Now this here is extern becomes extern. So it becomes an allocator. Because I do feel like it's kind of like a method of allocation, right? It's an externally allocated thing. So I want to search for this and change everything to be the allocator instead. So we've got a lot of these are declarations. So we're going to have to change a lot of these declarations. Mostly it's OpenGL. Yeah, it's all that kind of stuff. Syscall. I mean, syscall, I want it to be actually at none. I do have at none, don't I already? Yeah, I have it for variables. I want to use it for procedures as well. Because, yeah, at the moment it's extern, which means that actually we have this extern syscall here, which is like pointless. It shouldn't be there. So where the hell were we? We wanted to find extern and do something about it. So let's have a go at this. So the procedure type node, it's not actually the procedure type node, is it? It's the procedure node now, which will have, like if we go back to our, we had Linux open before, didn't we? If we go back here, this is like applying this type information up to here to the identifier, and then it's also applying this allocator to the identifier. So now when we're here, it's not on the type node, it's here, and we don't need the hash. So if that allocator is external, I mean, I guess, should we be using the get allocator? Maybe we should. Do we have any more externs in here? We do. There's a few places where we use it. Okay. Well, it's probably like AST dot get allocator. Call it the procedure allocator. So if the procedure allocator is not extern, if it is extern, and if it is extern. Okay, what else we got here? Generating a procedure. So here actually, I think I want to come back to here when we're generating the program. This is where we're generating all our procedures. See, we say if the allocator is GLSL, then we do one thing, otherwise we do the static thing. But maybe if I change this to a switch, I guess with procedure, well, this is a call node. Yeah, with procedures, the allocator, we probably don't have to call get allocator, but maybe it's safer. Maybe it's good to just always call get allocator. So if we say get allocator, and then down here, that's the bottom. And so here we say case GLSL. And this is case static. Yeah, by doing call get allocator, we know we're going to get a result because it might be just empty. Yeah, so calling get allocator is important. Like that. So we have GLSL, we have static, and now we have extern. And for extern, we're just going to do this. We're just going to print. Where the hell were we? Yeah, right here. That's all we have to do. So then I think we can just take this out of here because this is generating a static procedure, a statically allocated procedure. Okay, so that solves that part. What else we got here? These are all declaration things. I guess we can maybe resolve those first. So if I go replace that with nothing, and then if I say bracket new line, oh, can I do that without? I can't do that without a regular expression. And change it to a bracket at extern. That's going to work for most of them, except for the ones with returns. And I'll just do those manually. Okay, I think that's got all of them. Oh, that does not need to be extern. Okay, so that's GL, there's GLFW. Oh, for whatever reason that doesn't have that value there anymore. Like so, we can replace this with nothing, and then everywhere there's a return, we manually put it on, like so, and then GLU only has one, there. Okay, now we have much less results. So here we're saying if it was extern or this, or if it's neither of those. So I think this code here is trying to figure out the name to put in here. Like, do we use this like full name, or do we just use, I mean, this, not this one obviously, but there should be other, yeah. Or do we just use, just the name without any prefixes and stuff? And if it's extern, then we say we don't use any prefixes and stuff. We have the allocator here. Oh, so I guess extern should be one of these options. But allocator should not be extern. Yeah, there might be some places where we need to add this to a list of allocators. So that's that one. The hell is this? Contains allocations if we're calling something which is not extern. So I guess instead of getting the directive of the type, we're actually getting the, well, we need to do get allocator, right? Let's do this right. And if that's not extern, so this probably needs to be a pointer. Like so. Here, we're making sure it's not an extern procedure. Is there anywhere else we need the allocator in here? No, we're setting the allocator, that's it. Okay. So let's get the allocator. What was it we were getting before? Getting the type, okay. And make sure it's not extern. Isn't there? Oh yeah, I thought so. So now we're making sure that it is extern. So maybe we'll get the allocator. And down here we'll say make sure that if the allocator is extern, then we should not have we have some messages. Cannot assign when using allocator. I just kind of like to have some consistency to like the way my error messages are worded. So cannot provide a message body. What did I search for when using allocator? When using the allocator blah, and we pass in the allocator. And then we'll say must provide a procedure body when using allocator blah. Yeah. Cannot decide when using allocator. Yeah, I think that's a kind of consistent error messaging. So now we want to go back to looking for extern. Ah, there is no more extern. I would not be surprised if this fails though. Ah, glfw invalid token. Oh, right. Yeah, that should not be there. Syscall has not been declared. Okay. Wow, syscall is maybe a syscall in double quotes. There we go. So I guess it's trying to do. Oh, this is type checking. It's looking for the identifier syscall. In CoreOS Linux. Let's close some of these. So it's like this syscall at line 36 is saying, hey, I don't know what syscall is. So it's within a procedure. Is it not getting copied down? So maybe we need to check the type checking context when it copies. Ah, it looks like it copies all identifiers. It does not discriminate. Syscall has not been declared. So this is type checking our identifier. Cannot find the identifier syscall. Why would that be? I'm jumping around so much that I'm getting lost now. Why would that no longer be found? When I went back to here, I was kind of wondering because like in some situations I thought maybe it will not register syscall because I think previously in some situations we were saying syscall has extern, so it's covered by that. Well, it still has extern. And I have a feeling that if we like comment this out, okay, now it's complaining that futex does not exist. Well, if we, if we like go like this, well, we probably need to go like that. Yeah, now it's just saying this syscall is not declared here. So it seems to be any procedure Yeah, it's like within the procedure it's not being found. Like if I do syscall 0, 0, well, I think I can just do 0. If I do that, I think that's not going to complain. Yeah, it would have complained about that before it complained about the other one. So somehow it's not coming down. Oh, I don't do the copying down thing anymore. Not into a procedure. It'll be doing the it'll be doing this get identifier node. So it should be looking up the path and finding it in the path. Shouldn't it? All I did was change xturn. So these are the places that I changed. So those were the two checks. When we're doing a call, if it's not xturn, then we don't care about this stuff. No, I mean, if it is xturn, we don't care about that stuff. That makes sense. If it is xturn, we do the parameters a lot differently. And if it is xturn, we return a different value. Like that all makes sense. Oh, yeah. So there was like, I said when I did this, I was like, hey, there's probably some other places where we need to change this. So like, is static procedure. I feel like xturn, I'm going to consider a static procedure. That was probably a big problem. These are specifically xturn. This one is xturn. This one is specifically glshell. Yeah. Yeah, hopefully that was it. Syscall's not been declared, come on. So xturn, a static procedure is xturn. So if we go back to, of course this is the way, right? I'll just do one more little thing. If we go back to here where we're doing our static procedure, so this is where we catch it. So I'll say if, well, I guess we want this guy here. So if that is syscall, then this is my hacky little way to break. So it is finding it as a static procedure. Allocator is xturn. Oh, okay. Something just went in my head, went off in my head. Type checking identifier. Here, see, look at this. Oh no, we grabbed the identity. We do grab the allocator. I was thinking we weren't grabbing the right information here. Crap, I was hoping that would be it. Okay, let's go back to here. Oh, did I take the breakpoint out? Okay, so what's this called? It's an identifier, the type of procedure, all that good stuff, and allocator extern. So we add it to our list of procedures with qualified name. Ah, with a qualified name. We're adding it to our list of procedures with a qualified name. No, I think that's okay. I think that's okay. We add it to identifiers with just the regular name, just syscall. We add it to our queue of procedures to take care of, which means that when we go back to type check program, it's going to come in here and type check it. I have no idea what the problem is here. Identifier node, so node value is, so we're doing syscall and our context, I guess, is core and then OS Linux and then the procedure name. We have 4 identifiers in there. So I guess actually if we go back to statements, we steal this and then come back to wherever we were here. So if we're referring to syscall, I want to see what happens when we go into get identifier node. Okay, so it should not be any identifiers. So we've got the qualified name of this procedure, should not be in those identifiers. I think they should be actually empty. Yeah. Does it make sense even to do that? Because shouldn't this be, I don't know, let's not mess with that. So then we should go to the next iteration of the loop. That's the module procedure. It also has no identifiers. But then maybe the module does. I hope the module has identifiers. It does. It has 20 identifiers. And it finds it. Oh, but it's not visible. Oh, because it was get allocator equals. So it didn't show up in my searches. large here. Oh man, what a mission that was. Because I was kind of hoping actually to do this one as well, but we're at an hour 20, so let's not do that. Let's not tempt fate. But I'm happy we've got that sorted. Turn that into an allocator. So we have a few allocators now. We have extern, none, which doesn't work for procedures yet, but I want to do that. Static, stack, heap, VRAM. We have a few different allocators. And GLSL, but that only works for procedures. Okay, so yeah, so that's it. That's enough for now. All right, get out of here. Thanks for stopping by. See you next time. Ciao for now.